Okay, so till now we have studied unit 1 of this subject, and some part of unit 2 also has been covered. But let us start this unit 2, which is very important, and material science and engineering, to understand the properties of the materials uh, which our engineer as a mechanical engineer uses. So it is a very important unit. Okay, you can see as per the syllabus, you can see that mechanical properties and testing is the major part of this unit. Okay, mechanical properties and testing. So to start this topic, we have to first understand what is stress, what is strength, and how we will understand the stress and strength. And then we will go that how this stress strain diagram will be plotted for different type of materials. Okay, then with the same diagrams, or with the same testing, we can find out what is stress and what is strength, how we can find out the toughness, hardness, fracture. So these are some other tests which are listed over here in this unit: toughness, hardness. You have studied this hardness and toughness in your first year in engineering mechanics, through the subject of engineering mechanics in the lab of mechanical engineering, right? But fracture आपने पढ़ा होगा वहाँ, but you have not gone through the testing of fracture, even fatigue. And creep you have studied there. And so these are the properties, mechanical properties: stress, strain, toughness, hardness, fracture, fatigue, creep, right? And to find out these properties, or to understand better these properties, we will go for some testing, or we will understand this testing method, uh, and by performing those testing, or by understanding those testing, we will be very clear to understand the properties of these mechanical properties of the materials. So, and then there will be some another uh, testing which is for the microstructural exams. That is also in under the this sketch. Microscope structure examination करने के लिए we have to go with some microscopic principle and methods. For that testing, we have to prepare the samples, and microstructure exams and grain size determination can be done with the help of this particular testing. And there will be a comparative study of microstructure of various metals and alloys such as mild steel, cast iron, and brass. Okay. Then later on in the last of this unit, we will go to understand a little bit about the phase diagram and equilibrium diagram. Okay, phase diagram and equilibrium diagram. Okay, so and then in unit 3, we will go uh, deeply into the iron carbon equilibrium diagram, where while this time in this unit, it is a little bit the fundament to understand the phase rule, engineering binary diagrams, type of equilibrium diagrams, solid solutions, and some other terms. Okay, so let us move to the next slide. That is related to the very first property, stress and strength. So we know we have, as you know, this particular unit is to find out the mechanical properties and testings for various materials, and we know that materials are, we can define the materials in this type: metals, polymers, and ceramics. Basically, there are three type of materials: metal, ceramics, and polymers. And when we apply, when we tailor these materials in two or three, then it becomes composite. Okay, so namely we have four type of materials: metal, ceramics, polymers, and composite. This is the classification of the materials, which is very a very big one, which you have studied earlier also. There are some natural materials, there are some man-made materials. This is natural materials which was under the Stone Age, where stone, skin leather, mud, clay, wood, these were the major, and bone and worry. These were the major elements, major materials which was used in Stone Age. But finally, from mud and clay, we got another two type materials, and from wood, we have gone under. When we analyze the wood, we have selected, we have able to understand the type of wood, softwood and hardwoods, and then different grades and open grain and closed grain. Then we have understand that how the wood can be utilized by engineering it in a technical way. Then you will see the man-made materials are polymers, ceramics, and metals. So this is the classification which I have shown you before in the last slide. And metals, alloy and refined ores, and then from alloy, the polyalloys and the binary alloy, and from refined one, the elements and metalloids, right? And if we'll go to the ceramic side, then you will see the glass, right? And some ceramics are the type of the ceramics. You will see in the polymers, you will see plastic and elastomers. In plastic, you have the two type of plastic, thermosetting and thermoplastic. So this is all the classification of the materials, and we are supposed to understand the properties of the materials. ये सब वो मटेरियल्स हैं जिसमें हम जिनकी प्रॉपर्टीज के बारे में हमें पता होना चाहिए एज engineer, but normally we are more concentrated to understand the properties of metals and ceramics. Somehow we have go to polymers. So, and if you come to the properties of the materials, then there are four type of materials. Sorry, properties. Material properties are classified into four types: chemical, physical, mechanical, and dimensional. Chemical properties: composition, oxides, composition, alkalinity, and corrosion, etc. If you go to the physical property, there are density, conductivity, thermal, electrical, acoustical, sound, and transmission, absorption. If you go to mechanical properties, then yes, they are not about it. So strength, maybe tensile, compression, all toughness, stiffness, elasticity, plasticity, ductility, and brittleness. And if you think about the dimensional properties, then certainly it is related to the size and shape. Coming to now the stress and strain. Are you listening me? आपको सुनाई दे रहा है ना? Please tell me.
Yes, sir.
Okay.
Yes,
So
sir.
everything is clear ना? If there is some disturbance, let me know. Okay? मुझे बताएं आप. अच्छा. Okay. ठीक है ना?
Okay, sir.
Right. Thank you.
Okay.
Now see here. I would like to tell you that what is stress basically. Though you have studied this, but let's in Hindi it is called as pratibal. Stress is what? It is a property of a material which offers the resistance to deform on the application of any kind of force. Means यहाँ क्या बताना चाह रहे हैं कि किसी भी तरह का कोई हम अगर फोर्स अप्लाई कर रहे हैं, look at this application of any kind of force, there must be some resistance. Okay, so this property which offers the resistance, मतलब जैसे ही वो प्रतिरोध करता है बल लगाने का, चाहे वो इंटरनल फोर्स है या एक्सटर्नल फोर्स है ना, तो उसको उस टाइप उस रेजिस्टेंस को की वजह से जो प्रतिबल पैदा हो रहा है उसको हम क्या बोल रहे हैं? स्ट्रेस बोल रहे हैं, which is called in हिंदी प्रतिबल. बल, प्रतिबल, force and stress. Okay, mathematically it can be represented as sigma is represent to this F applied force and A cross sectional area. So sometimes mathematically we explain this as stress is the applied force or resistance force. देखो मैंने यहाँ पे applied force लिखा है. Why I have written this applied force? It is always equals to resistance force, which I am talking about here. Okay. So applied force or resistance force will be always equal, and cross-sectional area will be the area on which this force will be applied. So force upon area, that is Always remember this applied force is equal to resistance force, but we have to always remember that resistance force will be always equal to applied force. So unit, what will be the unit? If we'll take the unit of force, that is Newton, we'll take the unit of area in MK system, that will be meter square. Okay, so Newton per meter square. Sometimes we take millimeter square also in place of the meter. So area unit may be millimeter square also. So Newton per millimeter square, sometimes we name as megapascal. Okay, we use these three units. Normally, sometimes we use a gigapascal also when we use to find out the modulus of rigidity. आपने सुना है modulus of rigidity, isn't it? Okay. So here is resistance. Let me tell you once again. एक बार आपको फिर बताता हूँ resistance force क्या है. It is resistance force is induced in the materials will be always equal and opposite to the direction of applied force. Okay. Depending on type of applied force, the stress may be of different type. Tensile test आपने सुना होगा, compressive सुना होगा, and shear stress सुना होगा. Okay. So this way it is the stress. What is stress? You understand well here. Now we will come to the strength. Strength. Okay. What is it? It is the value of maximum stress in a material under applied load before fracture. अब होगा क्या? जब भी आप किसी मटेरियल पर कोई लोड अप्लाई करेंगे तो क्या होगा? सबसे पहले तो हमारी बात समझ में आएगी, रेजिस्टेंस उसमें डेवलप होगा. ओके. उसके बाद हमारी क्या समझ में बात आई कि डिफॉर्मेशन भी होगा मटेरियल के अंदर कुछ, और वो जो डिफॉर्मेशन होगा तो वो ऐसा तो नहीं होगा एकदम से हो जाएगा, धीरे 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 बढ़ेगा. और होता क्या है कि एट द एंड क्या होता है कि जो ये फोर्स है उसकी वजह से डिफॉर्मेशन होता है, लेंथ या एरिया कुछ भी बढ़ेगा घटेगा, एंड फाइनली इट विल फ्रैक्चर. तो टूटने से पहले बिफोर फ्रैक्चर जो मैक्सिमम स्ट्रेस आएगी उसको हम बोलेंगे स्ट्रेंथ. In case of the tensile load, it is called as tensile strength TS. As per the stress strain diagram plotted during tensile testing, the ultimate stress is known as tensile strength. वो आपको मैं आगे भी समझा दूंगा. But strength में tensile strength है, ultimate strength है, और एक हम बोलते हैं yield strength. So there are some type of strength also, right? Strength can be at any place, but till it is not the yield, tensile, this, that, तब तक हम टेंसाइल स्ट्रेंथ किसको मानेंगे? स्ट्रेंथ किसको मानेंगे? मैक्सिमम स्ट्रेस को. जबकि स्ट्रेस फ्रॉम द स्टार्टिंग टू द फ्रैक्चर पॉइंट देयर विल बी डिफरेंट टाइप. ठीक है. ओके. सो एंड अनदर टर्म yield strength and fracture strength is also used to describe diagram. जो हम डायग्राम से जो बताएंगे वो होती है आपकी yield strength, और इसी yield strength को इंजीनियर जो डिजाइन में लेता है. क्यों लेता है? Because the yield strength is usually taken in engineering design because only elastic deformation is considered. Okay. Are you clear till now? Say yes or no.
Yes.
Okay. Right. So अच्छा, कुछ लोग चले गए. पुष्पेंद्र बचे हैं केवल. Anyway, no problem. So पुष्पेंद्र, let's move ahead. देखो स्ट्रेस स्ट्रेन डायग्राम की हम बात करेंगे. ओके. व्हाट इज स्ट्रेस स्ट्रेन डायग्राम? द डायग्राम प्लॉटेड बिटवीन स्ट्रेस एंड स्ट्रेन. क्लियर? It can be plotted for any material such as ductile and brittle. This diagram is very much useful to find out many properties like strength, which I told you before. अभी मैंने पीछे बात की. Deformation, that is what? The change in the dimension. The change in the dimension will be, the change in the dimension may be length, maybe area, maybe shape, okay, and ductility, modulus, etc. There are so many properties which are associated to find out with the help of this stress strain diagram. Okay, so it is required to perform a tensile test on a material to plot this diagram. when we apply any test, when we perform any test to find out the properties of a material, we have to prepare a specimen. हमको एक स्पेसिमेन बनाना होता है, और स्पेसिमेन के डायमेंशंस होते हैं, दैट स्पेसिमेन डायमेंशन आर normally taken under or from the guidance of ASTM, that is American Society for Testing and Materials. There is a society which is universally adopted, okay, to find out the properties or to prepare the specimens and the directions how to perform the test. That society is normally ASTM is known, that American Society for Testing Materials. Okay, so you'll see that the dimensions are like this: 12.8 mm dia, length of reduced section 60 mm, and gauge length is 50 mm. You'll see this is here. See, this is the diagram. Okay, you can see. So this particular is the gauge length. That is, I have shown you there 50 mm. You can see over here 50 mm. But what is the 60 mm length? This is the length from reduced section, यानी यहाँ से यहाँ के बीच में ये जो length है, this length is called as reduced length, and this is usually taken 4 times of this area. We'll say this will be the diameter, and this diameter is normally taken as 12.8 mm diameter. It is in case of the metal. So if you, it is normally this length is taken 4 times of this. Okay, agree? Understand?
Okay, sir.
Understand about
Understand.
this? Okay, right. Now, see, this is the diagram, and this is the machine on which we can plot, or we can perform this test. So this is the specimen. We have clamped this specimen over here. ये दो आप देख रहे हैं, आपने मशीन देखी भी होगी. You have seen such kind of machine in our laboratory in first year. Have you seen that?
जी सर.
Yes. इसको
जी
हम
सर.
हाँ, इसको हम यूनिवर्सल टेस्टिंग मशीन भी बोलते हैं, you know. तो इसके एक जॉ इधर एक इधर, दोनों में क्लैंप करने के बाद में ऐसे देयर इज अ डिवाइस. दिस डिवाइस इज कॉल्ड एज एक्सटेंसोमीटर. व्हाट इट डिड, ये क्या करती है, इसकी लेंथ को मेजर करती है अंडर द एप्लीकेशन ऑफ लोड. तो जब हम लोड अप्लाई कर देंगे तो सी stress is at that axis, this axis it is stress, and at this axis we have strain. Okay, तो जो लोड है हमारा, जो जिससे हम स्ट्रेस फाइंड कर रहे हैं, उससे हम एक फोर्स की एक हम लोड डिसाइड कर देते हैं in terms of suppose Newton, and it rates is fixed. Per unit time कितना लोड बढ़ता रहेगा. So that is why sometimes it is called as gradual load, gradually increasing load. Okay, so once we will apply the force, right, there will be the tendency into the material to resist it. वो उसका रेजिस्टेंस डेवलप हो जाएगा. उसी रेजिस्टेंस को पर यूनिट एरिया हम क्या बोल रहे हैं, स्ट्रेस बोल रहे हैं. ओके, तो वी विल प्लॉट दिस दैट वैल्यू एज पर दिस एक्सिस. ओके, दिस इज व्हाट y axis, and whatever the change in length will be there, that will be by the help of that delta L upon L, where this L is the original length, this one. Okay, and delta L will be what, the change in length, which will be recorded by this extensometer. Okay, okay, is it clear to you, Pushpendra?
जी सर.
Okay, I think you have open your हाँ ओके। अनम्यूट अनम्यूट तभी करो जो पीछे से कोई बैकग्राउंड नहीं आ रही है, आपकी आवाज नहीं आ रही ना किसी की, तभी करिए, अदरवाइज इसको बंद रखिए। ओके, जब मैं पूछूं तब आप अपने फोन को, यस थैंक यू। ओके, so this is what I was trying to tell you, that how the stress strain diagram, stress is find out and how the strain is find out, and we will locate the value of stress and strain at a time. Suppose karo after 10 seconds, what is the stress? Okay, suppose it is over here. What is strain? It is here. After 20 seconds, this 30, 40, 50, 60, 70, 80. After time 10 मिनट या 1 मिनट 2 मिनट 3 मिनट 4 मिनट 5 मिनट के बाद में ये वैल्यूज हमारे स्ट्रेसेस के हैं, उसी हिसाब से आप इधर स्ट्रेन की वैल्यू भी फाइंड करके आपने प्लॉट कर ली। एंड देन फाइनली यू हैव drawn these lines like this and these lines like this, and you will get some cross points. So these cross points will be there, which will be, and when you will join those points, you will get a diagram. That diagram will be called as stress strain diagram. Clear hai? Now you
Yes,
can, okay. So this is the diagram by which you can understand, and then we will come to understand कि देखो पूरा कहीं तक एक straight line रही है, उसके बाद में थोड़ा सा change हुआ है, फिर थोड़ा change हुआ है, and then it goes like this, and after this point it goes down. So by understanding the behavior of this curve, we have interpreted the results in different terms. हम देख रहे हैं कि इस पॉइंट तक, ये देखिए इस पॉइंट तक, ये जो मैंने यहां तक हम क्या देख रहे हैं, स्ट्रेस इज प्रोपोर्शनल टू स्ट्रेन, स्ट्रेट लाइन मिल रही है हमको, मीन्स व्हाट, दिस इज कॉल्ड एज प्रोपोर्शनलिटी लिमिट। क्यों? स्ट्रेस इज प्रोपोर्शनल टू स्ट्रेन इन दिस लिमिट। आफ्टर व्हाट वी सी दैट अ पॉइंट इज देयर, कि अगर हम वहां तक देखते हैं तो इसको इलास्टिक लिमिट बोला है। क्यों बोला है? क्योंकि वो लिमिट है जहां पर तक अगर आप फोर्स अप्लाई करके यू विल लीव द मटेरियल, और यू विल लीव द मटेरियल अंडर अनलोडिंग। आपने लोड लगाया यहां तक और फिर आपने फोर्स को हटा लिया, तो यू विल सी द स्पेसिमेन विल बी लाइक दिस अगेन बैक, देयर विल बी नो चेंज इन टू द डायमेंशन रिमेन्ड। दैट मीन्स व्हाट, इसका मतलब हो गया कि इसका मतलब ये हो गया कि जो डिफॉर्मेशन है दैट इज रिकवर्स, और उस बिहेवियर को जो बोला है दैट इज कॉल्ड एज इलास्टिक लिमिट और इलास्टिसिटी और इलास्टिक बिहेवियर। आफ्टर दैट व्हाट हैपेंस, you will further apply the load, then you see it is called yield. But in practice what happens, उस कर्व को आपने देखा होगा कभी, अगर आपको ध्यान हो तो इस तरह का कर्व आता है, you will see like this cover, this type of cover. Somewhere you will find the diagram like this. So this particular phenomena is called as yielding. This particular phenomena is called as yielding. Yielding means you are not giving input, but you are getting the output. That is called yielding. So what happened over here? In this range, if I magnify this, so you will see, is there any? No. So you will see, let me share the whiteboard, please, so that I can explain this term very well. Okay, see, what I told you that these are the axes, and we got the diagram like this. And here I'm telling this particular is the YIELD yielding phenomena. Here is stress and here is strain. Here is strain. this is the region which I'm telling, I'm about to explain that it is yielding. See, यहाँ के बाद देखिए आप इस पॉइंट के बाद क्या हो रहा है. If you see between this to this, इस पॉइंट से इस पॉइंट के बीच में देखिए, इस पॉइंट से इस पॉइंट के बीच में देखें तो you will see there is a decrement. There is a decrement in the value of stress. While if you will see at this axis, at the axis of strain, you will see there is an increment into the strain. So without increasing the force, we are getting the strain. बल्कि उससे पहले क्या हो रहा था, जब हम फोर्स दे रहे थे तब हमको स्ट्रेन मिल रही थी. अभी क्या हो रहा है, you will see from this point to this point the stress is decreasing, or I must say load is decreasing, load is decreasing, load is decreasing, but strain is increasing. This phenomena is called yielding. That is why it is called as, from where the yield starts, upper yield point, where this phenomena end is called lower yield point. And this throughout this, from here to here, this is called yielding. From here, the further deformation requires increasing of load. Okay, so this is how we can explain, the stress strain diagram and the yielding. Ultimately, we reach at a point which is called ultimate point, and finally the material got fracture. So this is the value which is strength, or sometimes we say tensile strength. Okay, and this is fracture strength. This is what? This is called yielding strength. Okay, and at this axis we have the deformation. With the help of this, we can find out the ductility, percentage elongation. Okay, with the help of the percentage elongation, we can find out the ductility also. Okay, so this way, it is the method with the help of which I can explain you the stress strain diagram. Okay, and let's come back on this slide, because the time is about to finish now. The lecture is about to finish now, but let me complete. And what is the time now? 11:27. So my lecture must go on up to 11:40. Okay, let's let me come back to this slide. This one. Okay, so here we were here, and to let you understand what is yielding. Yielding को बताने के लिए मैं वापस उधर गया. Okay, and Pushpendra, can you hear me?
Yes, sir. Okay.
So is it clear to you? Yielding clear है? अभी आप अपना फोन को अनम्यूट करके रखिए. नहीं फोन को, हाँ.
Yes, sir.
तो things are clear, ना? Things are very much clear.
Yes.
Do
Yes,
you
sir.
have this? See, the range of yielding is over here, isn't it? और
Yes, sir.
यहाँ से यहाँ की जो हमारा जो डिफॉर्मेशन हो रहा है, इस पीरियड को में जो इसको हम बोल रहे हैं स्ट्रेन हार्डनिंग.
Yes.
Okay. और अल्टीमेट पॉइंट से जो फ्रैक्चर पॉइंट तक जब हम जाते हैं तो दिस इज कॉल्ड नेकिंग. क्यों नेकिंग बोलते हैं? क्योंकि नेकिंग फिनोमेना स्टार्ट हो जाता है, है ना?
Yes,
हमारा जो स्पेसिमेन है वो इस तरह का है. इनिशियली इट इज ऑफ दिस, and finally it at the end of the fracture it becomes like this. So from here to here there is a starting of the starting of necking, let me tell you. Okay, so this from, ये देखिए आप डॉटेड लाइन, ये डॉटेड लाइन से जो ऐसा हो जाता है, दिस इज कॉल्ड नेकिंग. So it can be better explained from this. Okay. Now see, the
जी
one thing only remaining, that is there is a deformation behavior. जब आपने लोड अप्लाई किया था, right, and the material started to deform, we'll see the deformation are in two form: elastic behavior and what is this? Plastic behavior. So total deformation is
प्लास्टिक
divided
बिहेवियर
into two part: elastic deformation and plastic deformation. Elastic deformation is up to elastic point, elastic limit, and elastic limit के बाद में जो deformation होना है, that will be known as the
प्लास्टिक प्लास्टिक
plastic behavior या deformation. So this is the way how we can explain this. Now अगर यही डायग्राम हम प्लॉट करते हैं, stress and diagram for brittle material, what will happen? Brittle material में plastic deformation नहीं होता, तो क्या
नहीं
होगा?
होता, तो
कर्व कहां तक रहेगा? अप टू ओनली दिस पॉइंट. इतना जो पार्ट है कर्व का, दिस विल नॉट बी इन केस ऑफ ब्रिटल मटेरियल. क्लियर हो गया? यस, हेलो, गुड.
यस
So it is clear to you. So we have understand the stress, strength, stress in diagram for ductile and brittle material, stress versus strength, and okay, tomorrow जो भी मेरा next lecture होगा, in that I will go to the some part of the testing, toughness, hardness, this and that. Okay, so this complete will be in next lecture, and in the further next lecture I will explain this one. Okay, because it is very small part, but this is very much important to understand. So this was to let you clear about it. Now if you have any kind of queries, questions, please ask. जो भी सवाल आपके हैं आप जरूर पूछें. इस डायग्राम पे भी आ जाते हैं, जहां भी आपको सवाल हैं आप पूछिए, तो सवाल जरूर पूछिए. जो भी आपको लगता है कि मेरी ये समझ में नहीं आया, तो यू कैन आस्क प्लीज.
सर एक तो वो था उसमें जो न्यूटन पर मीटर स्क्वायर था, वो न्यूटन mm स्क्वायर इक्वल जो यूनिट बदल रही है मीटर से mm में.
सी तेरे से और या तो ये लिख सकते हैं, या तो ये लिख सकते हैं, या तो ये लिख सकते हैं. जब हम एरिया को मीटर में मेजर करेंगे तो न्यूटन पर मीटर स्क्वायर आ जाएगा. जब एरिया को हम मिलीमीटर में लेंगे तो न्यूटन पर मिलीमीटर स्क्वायर हो जाएगा. ओके,
mm स्क्वायर हो जाएगा.
हाँ, नॉर्मली इसलिए लेते हैं क्योंकि डायमेंशन जो है ना, जो चेंज होता है वो बहुत कम होता है, डिफॉर्मेशन ना, तो इसलिए नॉर्मली हम जब स्ट्रेस निकालते हैं तो वो चेंज इन डायमेंशन बहुत कम होता है. या क्रॉस सेक्शनल एरिया ले सकते हैं, जो भी ले सकते हैं, क्योंकि वैल्यू बहुत ज्यादा आती है, 400 मेगा पास्कल. दैट्स बिग यूनिट. ओके, एनी अदर क्वेश्चन प्लीज? वेरी गुड क्वेश्चन. यहाँ आपको कहीं कुछ स्ट्रेंथ में कोई चीज पूछनी है, स्ट्रेस एंड डायग्राम में, फिर जब हमने यहाँ कुछ आपको लगता है कोई चीज समझ में नहीं आई?
यहाँ तो सर समझ में आ गई.
वेरी गुड.
हाँ तो ठीक है.
बस तो ठीक है. यहीं से देखो, इस वाले इससे स्टेज से ही हम क्या निकालते हैं? मॉडुलस ऑफ इलास्टिसिटी. क्योंकि इसको हम क्या कर देते हैं? सिग्मा इज इक्वल्स टू एप्सिलॉन इनटू ई. तो ई क्या है? मॉडुलस ऑफ इलास्टिसिटी. तो एक प्रॉपर्टी यहां से हमारी नहीं आ जाती है. इन केस ऑफ टेंसाइल इट इज इलास्टिसिटी. इन केस ऑफ जब हम उसका रिजिडिटी, मॉडुलस ऑफ रिजिडिटी निकालते हैं, वो किस में होता है? कंप्रेसर में, है ना. और इन केस ऑफ व्हेन यू आर अप्लाइंग सम shear force, So there we got the modulus of, I mean, bulk modulus. There are three, elastic constants. One is the modulus of elasticity, bulk modulus, and modulus of rigidity. So modulus of rigidity is a normal taken